All right, let's move on to question 4. So let f of x as negative x squared plus a when x is smaller than 3, and 5 times x negative a when x is greater or equal to 3. If f of x is continuous over the entire set of real numbers, what is the value of the constant a? So first, looking at this f of x, it's split into two cases like this. In each interval, the function is defined as polynomial, which means it is guaranteed to be continuous within those intervals. So, for the function to be continuous over all real numbers, we just need to check continuity at the point where the definition changes, that is, at x equals 3. So, in other words, if the function is continuous at x equals 3, then f of x is continuous on all real numbers. Now, for a function to be continuous at x equals 3, we need to check the basic definition of continuity. The basic definition of continuity is that the limit must be equal to the function value. But before that, in order to satisfy that equation, the limit has to exist. So for the limit to exist, the left-hand limit and the right-hand limit must be the same. So limit of f of x when x approaches from the left, and then limit, but it's right-hand limit, so it's plus, right? So first of all, these two need to be equal for the limit to exist. So this is the limit value. Plus, if that value is also equal to the function value, which is f of 3, like this, right? Then the function is continuous at x equals 3. So therefore, if this equation holds, then f of x is continuous at x equals 3, and based on what we discussed earlier, that means it's continuous on the entire real numbers. So now let's plug in the actual function and see what happens. First, for the left-hand limit, since x is approaching from the left-hand side of 3, we can look at the part where x is less than 3. So we use the expression negative x squared plus a. Let's plug that in. Now second, when x approaches from the right-hand side of 3, x is definitely greater than 3, so plug this in. Like this. Now finally, the function value. It's just simply plugging 3 into x. So it's 5 times 3 negative a. Alright, so now we need to calculate the limits. But since these are all polynomial functions, right? We can just use direct substitution. So let's just plug in 3 into each expression. So it's negative 3 squared plus a equal to 5 times 3 negative a equal to 5 times 3 negative a. So it's negative 9 plus a equals 15 negative a equals 15 negative a. But since 15 negative a is equal to itself, so there's no point in writing it twice, so let me just erase this. Now we can just solve this linear equation in terms of a. That will give us the final answer. Let's move all the terms with a to the left side and all the constants to the right side. So first, let's add a to both sides. So add a both sides. Negative 9 plus a, which is 2a. And right side is 15 minus a plus a, just 15. Now let's add 9 both sides. Then negative 9 and positive 9 cancel each other out. So 2a equals 15 plus 9, which is 24. Now divide both sides by 2. Therefore, A equals 24 over 2, which is 12. All right. Then finally, the answer is choice number 3.